All right, well, good afternoon, everyone. We're glad you're here. Welcome to the final webinar in the GCOOS Marine Heatwave Series. My name is Chris Simonello, and I'm the Outreach and Education Manager for GCOOS. I've had the pleasure of co-organizing this series with Dr. Renata Kamakoro, who many of you have already met. She's wrapping up her time with GCOOS as a National Academy Science Policy Fellow. Ren has been a valuable member of the GCOOS team and will no doubt go on to do great things as the Killam Postdoctoral Fellow at the University of British Columbia. After wrapping up work at GCOOS to better understand marine heat waves and their impacts on the Gulf region, Ren will be working on the intersection of urban forestry, city and regional policies, and community-level resilience initiatives. Hopefully, Ren, not too far from the ocean. We've gotten used to having you here. We like it. So while the first two webinars in the series were focused on the impacts of marine heat waves on marine species, today's presentations consider their impacts on coastal weather. We hope the talks make you aware of ongoing work in the space and promote dialogue on how the ability to forecast these events can aid public health and safety and community resilience. The webinar format will be 10-minute presentations followed by time for questions. To ask a question or share a comment, please use the question box option. Last week, we experienced a little bit of difficulty trying to unmute everybody. We'll try it again after the talks today, but if not, just be aware you can put those questions in the chat box there. So Ren, I'll hand it off to you to do the introductions. Thanks.
Yeah, thanks so much, Chris. And thanks everybody for joining us for our last webinar of this series. It's been great. I've learned a ton already, so really pumped that y'all are joining us for this last one. For those of you who were on the previous ones, you've heard a little bit of this spiel, but just to catch everybody up, basically, yes, I've been spending the last year or so looking at marine heat waves and their impacts in the Gulf and Caribbean region in particular. And the goal was to understand what we already know about what marine heat waves do to our communities, species, ecosystems, and industries. And when we were looking at that, it became clear that there's some stuff we do know, there's a lot of stuff we don't know. And so this has been a great chance to bring together experts who can talk a little bit about how their work intersects with marine heat waves, the questions we still have, what we understand, and where we go from here. So really excited to have one today that's focused a lot on weather and health. I think that's a really important one, especially as we move into the really, really hot season and the hurricane season that we're already in. One last minor housekeeping thing just to note is this is being recorded. It will be shared on GCOOS's YouTube channel later, so you can share it with folks who didn't make it. And the other ones are already posted there, so you can catch up on the ones that you might have missed already. And also, you should feel free to post questions in the questions pane whenever. You can drop them at any time. We'll be talking about questions, as Chris said, after each presentation, but there'll be a lot of time at the end for questions, and definitely welcome yours. So now I have the pleasure of introducing our speakers who are here today. So first we have Dr. Brian Dzwonkowski, who is an associate professor in the Stokes School of Marine and Environmental Sciences at the University of South Alabama, where he has been faculty member since 2014. Dr. Dzwonkowski completed his PhD at the University of Delaware and his undergraduate studies at the College of New Jersey. His research is focused on understanding relationships between coastal/estuarine circulation and hydrographic conditions and the associated dynamics, as well as interactions between the coastal ocean and atmospheric phenomena. Next, we have Dr. Shawn Milrad, who is a professor of meteorology at Embry-Riddle Aeronautical University in Daytona Beach, Florida. Dr. Milrad's overall research portfolio focuses on extreme weather events in the context of climate change. However, his most recent work examines humid heat trends in the Southeast US and the relationship of humid heat to marine heat waves in the region. Originally from New York City, Dr. Milrad is passionate about educating and mentoring the next generation of atmospheric and climate scientists, as well as integrating undergraduates in high-level scientific research. And last, but certainly not least, we have Dr. Lozada Perez, who is a faculty fellow at Houston Methodist Academic Institute. Dr. Lozada Perez got her PhD in coastal and marine system sciences from Texas A&M University at Corpus Christi. Her research background is in mixed methods approaches, which allows her to approach sustainability with an interdisciplinary perspective. Much of her work has focused on how community perceptions and values influence resilience to both natural and man-made disasters, and how coastal communities adapt to changes in their livelihoods as a result of these disasters or shifts. So I think you'll agree we have a star-studded cast with us today. We're really excited to have these wonderful folks tell us a little bit about their work. So without further ado, I'm going to go ahead and start us off by kicking it over to Dr. Dzwonkowski to kick us off. We cannot hear you at the moment.
All right, how about now?
Success.
All right, and so how do I get back to my presentation? That much, it's not letting me escape. So can you guys see my presentation?
Yep, presentation looks good in presentation mode.
All right, let's see. All right, so yeah, okay. So thank you for that introduction. I'm Brian Dzwonkowski with the University of South Alabama and Dauphin Island Sea Lab. And today I'm going to be presenting some of my graduate students' work, Dev Rao. So if you have really hard questions, save them for Dev. You'll get his contact at the end of this talk. Give me the easy ones. In all seriousness, I'd like to talk to you guys about marine heat waves and particularly sort of mechanisms that drive the full evolution of marine heat waves. There's a lot of work out there that looks at surface expression of marine heat waves, but the full water column structure and evolution of these things is actually quite important, particularly when it comes to hurricane interactions, right? So the title of the talk is Understanding the Role of Salinity Stratification in Marine Heat Waves During Hurricane Season, right? And so why the focus on hurricane season? Well, typically, there's a lot of research coming out that's showing that interactions between marine heat waves and hurricanes is bad, right? And this probably isn't surprising. We know warm water favors tropical storm development, but this is an example back in 2020 that I published on Hurricane Michael, and that was a pretty incredible storm. It made landfall as a Category 5, and so it intensified from a 4 to a 5 as it went through a marine heat wave and made landfall. And so that's what you're seeing down here. This bright red area is, you see the track of Michael, the large circular dots. It goes through that big blob of red and makes landfall. And so that's sort of what was going on there, right? So the interactions typically have a bad result. Marine heat waves, we know, are going to be increasing in frequency, duration, and intensity. And so the interactions may become more common in the future, right? And so the important thing also is that marine heat waves, while a lot of the focus is on surface structure, interactions with the ocean and hurricanes have a three-dimensional impact, right? The vertical water column structure is really important. So things like tropical cyclone heat potential, barrier layers all play a role in storm intensification. So understanding the full vertical structure of a marine heat wave is really important for understanding whether or not how it's going to interact with the tropical cyclone. Okay, so with that in mind, the overall goal of this talk is to understand the subsurface evolution of a marine heat wave, particularly an area influenced by freshwater discharge, so a region of freshwater influence, in part to understand the role of salinity stratification in an event's evolution, and then also to kind of look at the physical processes that are driving the structure and evolution of that marine heat wave in this region of a region of freshwater influence. Yeah, so try to understand the relative importance of things like surface heat flux, coastal circulation, mixing dynamics, shelf break transport, those sorts of processes. Okay, so in order to do this, I need an area that is exposed to freshwater influences and is exposed to hurricanes, right? So hopefully all of you guys are sort of, already know the answer to this question. Northern Gulf of Mexico, right? Or excuse me, Northern Gulf of America, right? It's a hot spot for landfall storms. It's also a site for lots of freshwater discharge, right? We have the Mississippi River. You can see the bottom plot here is a satellite image of sea surface salinity. Red is high salinity, blue is low salinity. And hopefully you guys can see that the Northern Gulf is loaded with blue, so it's loaded with fresh water. This is during summer season, right? And that's not just from the Mississippi River, that is the big player, but local rivers also have a say in it, depending on region, right? So this is a good area to conduct this research. Next thing we need is a marine heat wave event, right? And so if we look at a particular event in the fall of 2019, peak hurricane season, the plot on the top right is a map of all the pixels during the fall transition in 2019 that experienced a marine heat wave event. Hopefully you guys can see it's generally the entire Gulf of America. And so this is a very large scale event, right? And so we're going to zero down on the shelf in and around the Mississippi Bight area. And we're going to do this for two reasons. One, it's very close to the Mississippi River, so it gets exposed to a lot of fresh water. And two, we have a mooring, partially supported by GCOOS, that has been collecting long-term data out there and can give us some insight into the vertical structuring of the water column, right? And we're also going to look at a reanalysis product lorries to get a better spatial idea of what's going on beyond just what's happening at the mooring, right? So if we look at the evolution of this event, and again, we're focusing on the Northern Gulf here. And so what you'll see is two columns here. You'll see one is surface, one is bottom, bottom being either the bottom pixel or the bottom being the 300-meter depth level. And so we go from late August, early September, mid-September to late September, basically. And what you're seeing here are pixels. If it is a color, that means it experienced a marine heat wave, and the coloration is the temperature during that marine heat wave, right? And so what you can hopefully see is the surface here is evolving where there's nothing going on in the Northern Gulf in early September, starts heating up mid-September, and then really expands over the entire shelf of the Northern Gulf in late September. This isn't really matched in the bottom, right? So the bottom, it's sort of isolated to the surface throughout most of September, right? So going down the far right-hand column, you can see some hints of a bottom marine heat wave showing up at the end of October, right? If we then go into October, what we can see is the surface continues to expand until the end of October, when it begins to decay, and that starts. And this is at this point in October is when we see the bottom marine heat wave really start to evolve, right? We can see it sort of become much larger, spread out over the shelf, and then sort of move offshore as the month of October goes on. And it's just by the end of October, it's just this filament along the shelf break. And so what I'm really interested in is understanding this bottom part, this bottom evolution. How does this sort of bottom evolve relative to the surface? In part because this is sort of hidden heat from a lot of our measurements are from satellite sea surface temperature, and so this bottom part is not going to be as readily understood or known about if you're sort of trying to forecast a hurricane, right? So this is kind of what I'm really interested in. So if we look at a cross section of the Mississippi Bight, right? So if we take a cross section that goes through our mooring area, and we go from the coast to the shelf break, and we sort of plot that vertical slice, that's what you're seeing here. And we're going from October, the end of September through October. What I hope you can see, the arrows sort of direct you to what you should look at. So we're looking at temperature, and we're looking at blues and greens. Those blues and greens warm up to greens and yellows, and then the greens and yellows go from yellows to sort of light red, right? So we see this bottom warming over the course of the event. We also see the surface cooling, right? So we see reds to greens, right? So there's this temperature inversion that's happening over that bottom warm layer, right? So that temperature inversion suggests salinity stratification is playing a role. Otherwise, it'd be unstable, and you wouldn't see that structure. But to get there was a number of things happening. There's some mixing dynamics, there's some downwelling dynamics, and there's some shelf break transport dynamics that I don't have time to get into. But as I mentioned, Deb Rao would be happy to talk to you about those aspects of the study. For us, I just want to focus in on what salinity stratification is doing, particularly on the tail end of this event, and how it insulates the bottom heat and allows it to linger, right? So that's really clear in the mooring, right? So if we go to the mooring, so this is, again, time, late September through November is the time axis. And then we have the top plot is depth. So this is the structure, the vertical structure. The redder colors are warmer temperatures. The bluer colors are colder temperatures. And then you also see a complementary plot, this line plot, where red is the bottom temperature. Blue is the mean temperature for that location, and the dashed lines are the 90th and the 10th percentile. And so in early October, you can see the red line overlaps the black dashed line, indicating a marine heat wave is occurring at the bottom, and that happens basically through the whole month. And that's coincident with the whole water column warming up. So you can see the red here in September in the surface. And then that transitions to a full water column marine heat wave. And then that eventually transitions to this bottom trapping, right? And so that bottom trapping is indicative of salinity stratification. So if we look at the salinity data, we can see that salinity does in fact play a role here. So if we take a cutout from around October 2nd to the end of the month, that's what you're seeing here. The blue is bottom salinity, the red is surface salinity. And what you can see is right when this bottom trapping is occurring, you see a re-stratification where the bottom salts. And so that stratification is providing a critical insulation of that bottom temperature, allowing it to linger for a much longer time than the full water column of the surface marine heat wave at this site. Okay, so this is just one point. Do we have evidence of this happening over the broader shelf? If we look at satellite data for the month of October, what we can see is that the whole area in the Mississippi Bight is generally fresher than the surrounding area, which suggests that there is salinity stratification across the shelf in October, which suggests that this is a pretty persistent process spatially over this area during this time period, and is consistent with what we were seeing in the temperature inversions that we were seeing in the GLORIES reanalysis data. Okay, so to wrap things up, we investigated the surface to subsurface evolution of a marine heat wave in a river-dominated area in the Northern Gulf. We noted that there's interactions between advection, mixing, and stratification that are all important in this vertical evolution. And we highlighted the role that salinity-driven stratification plays in the coastal zone, particularly leading to trapped heat in the and a subsurface marine heat wave. And again, this subsurface heat, the subsurface marine heat wave could be very important for predicting shelf intensification as tropical cyclones make landfall in this region, right? As I mentioned, there's a picture of Dev down here. There's his contact. If you have questions, you can obviously ask me now, but also feel free to reach out to Dev and sort of talk to him about this work as well. And with that, I'll just thank my funding sources, highlight a couple of the related publications that are out there in the literature related to the story. Yeah, I'm happy to take any questions that you may have.
Thanks, Brian. Yeah, I feel like we don't hear as much about, or we don't have as much data a lot of times on subsurface marine heat waves, which makes things a little bit harder to understand. So it's interesting to see kind of how you can end up with that stratification really changing the relationship between a surface and subsurface marine heat wave. I'm curious, since you've done a lot of work on hurricanes, when you're thinking about, I mean, you mentioned that this can be really helpful for predicting storm intensification or kind of doing that sort of work in hurricanes in particular. Can you say a bit more, like what do you think the difference would be made? Like, are we basically, our satellite data is making it so we don't see these subsurface temperatures that can lead to more intensification, or is there something else that you think would be really helpful for us to understand here?
Yeah, right. So exactly, the satellite data is just providing a surface measurement, right? And what really matters is as the storm is coming through, it's going to be mixing that water, right? So the surface temperature prior to a hurricane's arrival is useful, but we know that's going to change depending on what the subsurface structure of the water is, right? So if the water is cold below the surface, then, which is typically a normal level of stratification, warm water sits on cold water, right? So that's a typical setup in the ocean. You can basically have mixing that will drop the sea surface temperature, and you might expect a storm to weaken when you drop the sea surface temperature. But in a situation where you have a temperature inversion and the surface is colder than the subsurface, that water that's mixing is going to bring up warmer water and warm the sea surface temperature. And so you may get an unexpected boost in your sea surface temperature, which would lead to potential intensification. So that's part of the story.
Thanks. Yeah, that makes a lot of sense. An unexpected boost in a hurricane is not anything we want to be seeing.
No.
Well, thanks so much. Yeah. Thanks so much for that. We'll have time for a few more questions for Brian and perhaps for Dev a little bit towards the end. Thank you so much, Brian. Really appreciate the overview.
No problem.
All right, with that, I'm going to go ahead and pass it off to Shawn Milrad for our next presentation.
Okay, can you hear me okay?
Yep, you're coming in loud and clear.
Okay, well, thank you for having me. My name is Shawn Milrad. I'm a professor of meteorology at Embry-Riddle Aeronautical University in Daytona Beach. I'm going to talk a little bit about some of our work on the intersection of marine heat waves and humid heat within the region and the trends in both. I just want to acknowledge my co-authors, both one former, one current undergraduate student of mine, Samantha Stone and Katie Orletsky. So next slide. So the origin of this work, at least the branching out into marine heat waves really came in 2023 with the very anomalous event that happened throughout around Florida and parts of the Caribbean and Gulf as well. Here you can see the sea surface temperature anomalies on the left, and then a kind of zoom in of the Florida Keys and Cuba area, Bahamas in the middle. This heat wave really reached unprecedented levels, as I'm sure most of you know, about 38°C. Bleaching affected about 90% of the monitored reefs in the Florida Keys. So this really got our attention. It also got the attention of the NOAA Coral Reef Watch scale, because they added 2 new categories, which I highlighted there in the bottom right, AL4 and AL5, to their bleaching scale. So this was a really extreme event and got us wondering about the connections between marine heat waves in the region and humid heat. So next slide. Also want to emphasize on the humid heat front, the Southeast is a very vulnerable region. These are just some images from the most recent National Climate Assessment. Large projected numbers of extreme heat in the future, a region very vulnerable to mortality, as well as energy blackouts, with a lot of vulnerable people within the region. So we've been looking at humid heat for a while. And this work kind of brings together the stuff we've done on humid heat with marine heat waves. Next slide. So for the marine heat wave part, we did a 40-year climatology or event identification process and trend analysis. We used the Hobday et al. Marine heat wave definition, which is a local 90th percentile SST for 5 or more consecutive days. We applied the 11-day rolling average to reduce noise. We actually used 2 data sets. So we started with the NOAA OISST, which is sort of the standard satellite-based data set. And then we used the much higher resolution Coral Reef Watch SST data set, which is 5 kilometers. But we kept the 91 to 20 climatological period. So on the bottom left is just for the July 2023 marine heat wave. Everywhere that's sort of hatched, you'll see on July 23rd, which kind of was the peak day of that marine heat wave, basically the entire area, the entire basin exceeded the 90th percentile. And alongside that is the middle plot. Everywhere in red shows where there was a marine heat wave. In other words, not only was it the 90th percentile exceeded, but it had been so for at least 5 consecutive days. So a very widespread marine heat wave that had large impacts in 2023. And then on the right, you'll see the regions, and I'll come back to this later, that we divided some of our events into. So it was 4 different regions, and I'll talk about that as I go forward. So next slide. So some quick trends for marine heat waves. So frequency trends on the top and duration trends on the bottom. I'm only showing July, August, and September, but we did do it for May to October. Couple of highlights. You can see that basically there's statistically significant increases in most places, particularly in the Western Caribbean, as well as the Gulf and the Bay of Campeche. Couple of interesting things. We're talking about hurricanes. If you look at September there on the top right, you'll notice big frequency increases in marine heat waves in the Gulf Stream area. So that's very significant for hurricanes. I'm also not showing it, but this is from the Coral Reef Watch data set. And we found that the Coral Reef Watch data set really highlighted the increased trends along the coast. So you can perhaps pick out the large values along the Gulf Coast of Florida in July. That's one thing that really popped out in this high resolution data set as compared to the coarser OISST. So that was kind of an interesting find. But in general, marine heat waves are becoming much more frequent and longer as well throughout most, if not all, of the region during our study period. So next slide. Just to highlight this, the previous one plot showed linear trends. I want to emphasize that the linear trends really don't tell the full story. So these are the number of marine heat waves by our subregions. And this is for July, and you can hit to the next one. And I'll show August, and you really see how, there's sort of these small increases. Then you look at 2023 and 2024, and you just see these exponential jumps. And we found that very consistent, not only for each region, but also for most months. So it wasn't just limited to the peak of the warm season. You can hit the next one, and you'll see similar thing for September. So it's not just a steady increase in marine heat wave frequency. It's a kind of an alarming exponential increase, especially over the last 2 to 5 years, which is something that caught our attention. So next slide. And you can hit one more. All right, so now to the humid heat part. We've been working on this for a while. Most humid heat metrics only incorporate temperature and humidity. You can think of heat index or stuff like that. But both those are measured in the shade. So what we've been using for a while is wet bulb globe temperature, which is sort of considered the most accurate metric for humid heat on the human body. It incorporates temperature, humidity, but also solar radiation, wind speed. So it basically tells you the impacts of humid heat in the full sun, which a lot of people, when they're experiencing humid heat or working in humid heat, that's how they're experiencing it. And this was originally developed by the military, but is used throughout athletics and occupational health and safety as well. Next slide. So these were from our paper last year, looking at humid heat trends across the Southeast. And what we found was pretty steady increases, but stronger at night during the day. That is pretty consistent with a lot of research on climate trends. In other words, we think that the increased amounts of water vapor and the feedbacks are helping to hold in, keep both the temperature and the dew point higher at night than in the past. There are still some big daytime increases, primarily in Southeast Florida. Our biggest nighttime increases we found kind of in the Gulf Coast of Florida, as well as parts of Louisiana and Arkansas. So next slide. Where we really saw our biggest increases in humid heat were in the frequency of extreme events. So these are the increases in the frequency of 90th percentile events. And again, bigger at night on the right than during the day on the left, but really large increases close to warm water. So you see the Florida Peninsula, coastal Louisiana, parts of coastal Texas on the edge of the frame there. And we really think that the rising sea surface temperatures, rising ocean warmth is playing a role in helping these extreme nighttime humid heat events on land happen much more frequently. And that's the biggest difference between day and night. So next slide. And again, I want to emphasize this is not, although the previous ones show linear trends, take that with a grain of salt. These are the frequency of extreme events for 2 selected cities. So New Orleans on the left, Daytona on the right. New Orleans happens to be for nighttime, Daytona for daytime. But if you look at the jumps between, say, 2015 onward, it's really kind of an exponential increase or a big jump. So since 2016, New Orleans has seen over 23 extreme nights per summer in terms of humid heat, and similar for Daytona during the day. So it's not just a steady increase, it's very alarming increases, especially since around 2015 to 2020. Next slide. So we're at the very beginning of kind of investigating the correlations between the actual marine heatwave events and the humid heat conditions on land during those events. But this is kind of how we're doing it. So we have these boxes where the marine heat waves will have occurred on the left, and we also have our coastal boxes, which is looking at the wet bulb globe temperature over land. And we're starting to accumulate correlation statistics and co-occurrence statistics. We're also looking at kind of the length of how they were co-located or co-occurred. And what we're finding so far, as you can see on the right here, a lot of our longest events and a lot of our events period where these 2 types of co-occurred have happened in the past 5 years. So again, that speaks to how these changes are not linear, they're really more exponential. Next slide. And beyond that, what we're planning to do is kind of investigate the physical mechanisms that link the marine heat waves and the humid heat events. So one thing we're planning to do with examples on the right there, backward trajectory analyses, basically asking where did the humid heat air come from, right? And one thing we found so far, just using the simple trace of potential temperature, is that there's quite a bit of diabatic warming over the water before that air gets to the coast. And that's what we would expect if a marine heat wave was having a large impact. So much more of that to come. This has just started, but that just gives you a feel for where we're headed. And you can hit the next slide and I will conclude. If you're interested in some of our recent publications, especially on humid heat, there's a QR code there. At the top is kind of a cute graphic that one of my students made last year regarding coral bleaching and marine heat waves. And just many of you, I'm sure, have seen the climate stripes, but I'm just showing it there for the ocean temperature change as well as the local temperature change in Tampa. So this is a problem that is not going away. So thank you very much.
Yeah, thank you so much for that. Kind of, I suppose, distressing story in and of itself as we're seeing, you know, more and more heat waves and extreme temperatures, but important to look at nonetheless. I have a quick question, actually, I guess, which I don't know that you'll have an answer to this because you're still looking, I think, starting at this stage. But I noticed as you were looking at the increase in extreme wet bulb globe temperatures, especially at night, it is quite varied across our northern Gulf Coast. I'm curious, do you have a good sense of why, for example, parts of the Florida Panhandle seem to be hit not quite as bad as like the eastern or kind of Atlantic coast of Florida and what's kind of going on there? Because they're all by hot water, conceivably.
Yeah, that's a really good question. We've thought about maybe it's some of the shelf temperatures are a little bit cooler there. We need to, I think, investigate more of the linear trend versus the exponential jumps, because there's a lot of literature that if you go back for basically the 1970s, 1980s, much of the southeast north of the Florida Peninsula actually had a cooling trend. A lot of people think that was due to the aerosols in the 60s and 70s, dubbed the southeast warming hole. So there might be some of that sort of in the linear trends where it's taken longer for it to start to increase as compared to the Florida Peninsula. It may have to do with more of the dual coast sea breeze, land breeze. They're all possibilities, could be a combination. But yeah, that's a really good point. I think requires further investigation.
Yeah, I'm excited to see as you get to dive into it, what the patterns look like, especially non-linearly. That's definitely a part that important to highlight and something I definitely have not gotten a chance to dive into as much.
Yeah.
But thank you so much. That was really interesting. Excited to have
you.
some more questions for you towards the end.
Yep.
Awesome. All right. Well, last and certainly not least, we have Dr. Lozada Perez coming up, and I will get your presentation.
Sweet. So hi, everyone. My name is Cora Lozada Perez. I work with Houston Methodist. I am part of the Office of Sustainability. And so I'll be talking more about like how marine heat waves and some of the effects afterwards are felt on coastal communities and what that means for public health and resilience and sustainability within healthcare in general, healthcare systems. So if you could go to the next slide. So we'll talk about hurricane intensifications, harmful algal blooms, fisheries, and then last but not least, public health. Next slide. Just a little bit about me. My focus areas are more towards microplastics. We're just starting in that within the sustainability office, but community health, resilience, and One Health in general. Next slide. All right, so as we heard in the two previous presentations, marine heat waves can cause intensifications of storms, which is not a great thing for us on land. We have here, Methodist has 8 hospitals with spread around the counties that make up the greater Houston area. So these are some of our counties, all of which are affected when we have these intensified storms, rainfall events, things like that. Next slide, please. And finally, when we think about HABs, which we know can happen with these warmer temperatures, we see them aerosolized. There's fish and biomass die-offs, there's closures, there's these noxious smells that come out, and that really harms our coastal communities, not just in the sense of tourism, because people don't want to go fishing or things like that, but we actually have had to talk with communities that in the past have tried to take home fish that have to eat from these die-offs. So it's these type of public health themes that I'll be talking about. With the aerosolized HABs, when they're aerosolized, we do have these issues of people with asthma or aggravated breathing problems. They tend to come into our ERs. Since, like I said, we work in Methodist, we've seen an increase in ER visits due to some of these effects, not from HABs, but some of these effects of heat and also of, so like heat related issues, but also of from asthma. And so that really puts a strain on our resources. Next slide. All right, and then when we talk about fisheries, I really like the slide because it talks about these losers and winners, but estimated socioeconomic cost of marine heat waves exceeded almost 800 million in direct losses, or 3.1 billion in indirect losses of ecosystem services for multiple years. So you have some places where they're winning. I mean, we use that term loosely, right? The water's warmer for longer, there might be a better tourist season, or certain stocks see more availability, but that's not always a great thing. There was a paper, and I have it in the references, that talked about specifically with the shrimp stocks, how they increased and then, you know, shrimpers weren't able to sell for as much, so they didn't have a good year in that sense. So if you could go to the next slide, please. Okay, this is where I really get into it. So like I was saying, when we think about public health, we think about these kind of impacts that happen afterwards, right? So after these specifically looking at intensified storms. So we have heat related, we have respiratory, cardiovascular, vector-borne, and flood related. This is a wonderful graphic of what we mean, right? So if you go to the next slide, I believe I get into heat. Perfect. So when we think about heat, this is from a study that was done through HARC, the Houston Advanced Research Center, and they were mapping out, this was specifically related to heat island effect, but they looked at how extreme heat is increasing, especially in Houston. So we ranked 4th in the US for heat island intensity, and severe, it's a severe threat here. Our ER visits in 2024 were, I mean, just it was a shock. We had a lot of people that were passing out, waiting for buses, things like that. But the point that I wanted to really make is when we have these intensified storms, we tend to lose a lot of power. A lot of our communities, you know, get their power knocked out, and that's where a lot of the heat issues come in for us. Next slide. Another big one is flooding. So this is from the Kinder Institute. And so they did, this is looking at Hurricane Harvey, the 2019 storms, and Tropical Storm Imelda. And we're seeing that flooding has effects during, but also after on health, which is something to think about as we're seeing more of these marine heat waves, intensification of storms, and these after effects. A lot of these were emotional changes. So people not knowing how to deal with the mental health impacts. Next one. And then we also get with water quality. After these flooding events, we see a lot of our infrastructure compromised. So we see that about 60% of water streams found in the 3-county area, so Harris being the biggest one, are currently impaired with bacterial combinations, so it makes the water unsafe. And this only gets worse when we think about flooding, storms, things like that. Next slide. And then finally, this is kind of like the big piece of it all. So at the Sustainability Office and within the Harris County, for sure, Public Health Department, we are looking at public health through a One Health lens, where we take into consideration animal health, environmental health, and human health, because they all affect one another. And so there's some amazing things that are coming out of the Harris County Public Health Office, and in collaboration with other teams across the Harris County and Greater Houston area, looking at ways to really move this framework forward. I believe that was my last slide. Yeah, my references, and I can share more. Thank you.
Awesome. Thank you so much. That was, I think, a great way to tie together a lot of what we're thinking about, for example, wet bulb globe temperatures or hurricane impacts, but how does that actually translate? Besides things like just road damage, how does that translate into a lot of our human health impacts? And especially, I think the mental health and emotional impacts are ones that are often underappreciated. So I appreciate you highlighting that in particular. We do have time for our open discussion now, so I'm going to invite both Shawn and Brian to come back on video if they so choose, and very much encourage y'all to be dropping questions in the chat. If you have any, I have some queued up as well, but definitely if y'all in the audience have questions, feel free to throw them in. Okay, I guess one question maybe that I have for Coral here, since you just presented, I would love to hear a little bit more, I guess, yeah, what are the One Health initiatives looking like in the area? What is that concretely? What projects are kicking off to try to incorporate all these different forms of health for local communities?
Yeah, so right now the biggest one is our public health and our flood district put together a One Health in the Built Environment Toolkit, and it is a series of processes that you can use to when we look at using nature-based infrastructure and nature-based projects. And so that's a big one that I always point people to. You can kind of use it for a wide range of things. There is a One Health Hub, which is right now, it's various organizations that are all coming together to really promote One Health across. So we do have universities, we have health systems, we have some industry folks on there, and there's a tour coming in October where we're going to go around looking at the different One Health projects in the Houston area. Again, this is very focused here in Harris County and Greater Houston area, but there is also out of Texas A&M Galveston, they have a course on this on Ocean One Health. So it's coming up, and it's a wonderful way for also from a healthcare systems perspective for us to understand that we need to start tying in environmental determinants of health into our community health assessments and really understanding what our greater communities are going through.
Yeah, thanks so much. Exciting things happening in the Harris County or Greater Houston area, which is good. And I know there's some similar initiatives that are happening in some other places around the Northern Gulf as well. Yeah, awesome. We have a couple of questions in the chat that I'm gonna throw out. We've got one question, which is, I think this is geared towards Coral's presentation, but it honestly could work for, I think, a lot of y'all if you know the answer. So the question is, are policymakers made aware of your data and how climate change and marine heat waves are impacting public health and costs? Is that something that we're hearing, or are there connections that y'all have to policymakers in any kind of way?
Shawn or Brian, do y'all want to take this one, and then I can go with more, I guess, localized here?
Yeah, I don't really know, to be honest with you, from my perspective. Yeah, I'm not sure how much policy is being considering this.
Yeah, I think it started to be. There was stuff in the last National Climate Assessment that touched on this. I know that before it got disbanded, there was talk of it being much more expanded in that assessment in the next one, and both from a marine heat wave, marine policy perspective, as well as a humid heat health perspective. So those were both topics that were highlighted as room for expansion. But I would say it's probably on the newer side as far as getting into policymakers' heads and plans.
And I can say that from here in Harris, at least with the One Health Hub, that is what we're hoping to get to. There has been some effort through the Baker School out of Rice as well. Excuse me. So yeah, it's starting to. We're right now trying to get more I guess, letting our physicians and clinicians see the importance of it, and then hoping that they will advocate for this from our standpoint.
Yeah, I echo. I've seen some trickles starting, but I think we're definitely in the early stages, especially from a marine heat wave perspective, rather than just kind of some of these extreme events more generally, I would say as well. Awesome. We have another question that's I think also somewhat related, which is how do you, everyone, communicate the results of your work to the public, including policymakers, and showcase the importance of things like GCOOS and ocean observations more generally? I think this can be open to anyone who wants to hop in.
At the Sea Lab, we do a lot of local news media. So I'm often, especially during hurricane season, a couple of the reporters have me on dial-up. So I do a lot of local news clips. And I think generally, we're out there sort of, at least, I'm out there presenting in the standard scientific literature. I will say I don't make a whole lot of effort to go to politicians. It's sort of a realm where I just kind of, I don't know if that's my lane. And I report up to my director and say, hey, this might be good for a press release, and I talk to the Sea Lab about press releases, but that's, about what I do. I generally don't get engaged with the politicians.
Yeah, I would echo that most of that. I think we've made a pretty decent effort of reaching out to local and regional media. Just for example, there's a meteorologist on one of the Tampa network stations who has he always does a segment on climate related issues. He also has a podcast on climate. So we've been on his show with some of our research on humid heat and tried to get the word out regionally, in addition to the scientific outlets like conferences and publications. So I think it's important to really spread the word on a local and regional scale, as opposed to trying to do everything nationally or with politicians right away, because I think that often impacts more people and gets more done quicker.
Yeah, and I'll echo that as well. I'm a big believer in hyperlocal and knowing who your resources are in your communities. And if you can explain your research to your communities, that's the best way to go, because then they will share forward. So here in Houston, with local podcasting, with the universities, we're very lucky here that everyone's pretty interconnected, so we can get the research out and about, and in very what's the word, like public appropriate, with the right wording, and making sure that it's something that your 8-year-old can explain. So that's helpful. There's also, I will say, I'm working on a grant to do a webinar series for these types of things, for the environmental determinants of health, with across the Texas Medical Center, with all of our clinicians and physicians, just so they can get an understanding. Sometimes they know that these things affect their patients, but they don't have the time to really sit and think of like, well, we're in this watershed and this watershed gets affected this way, and this is why we're having. So that helps when you can provide information. So if anybody on here wants to be on the webinar, hit me up.
Yeah, I was gonna say, plug to our audience. I know we got some great experts in the audience as well. That's awesome. Yeah, thank you all. We have another question in the chat, which is, saw some cool graphics regarding the marine heat waves. Any public-facing tools or websites that y'all use to see marine heat waves? I have a couple that I'll drop in the chat, but if anyone else has ones that they really like, I'd love to see.
Yeah, NOAA's Physical Science Lab has an awesome web page that it's a little coarse for the coastal zone, right? It's using OI SST, but it's a really awesome. I mean, I love it. I use it a lot. So that's one of my main, like, I'm always curious about what's going on right now, and so I'm constantly checking it. And it's a global map, and you can kind of click on the location of your liking, and it gives you like a past record of like, oh yeah, last year was really hot. Gives you a perspective on how hot it actually was. How good is your memory versus what the data actually say.
Yeah, NOAA Coral Reef Watch has a lot of good graphics as well. They also have some coral specific metrics, such as bleaching alert area and some of the rating scale. I briefly showed. So and very high resolution data, which is nice. So I check that a lot. But yeah, more products the better.
The other one I'll plug, those are great ones. I use both of those. The other one I'll plug is I think it's literally marineheatwaves.org, which I want to say a lot of the folks who work on that are based out of Australia, I'm pretty sure. Yeah, okay, great. Y'all are nodding, so that makes me feel like it's probably that. But they have some really good global graphics as well that are similar to, I think, NOAA's physical sciences lab ones, but they're slightly different and the color scheme is slightly different. And I find that I sometimes look at them side to side and kind of mess around with it a little bit, and I found that pretty cool. And if I refine the chat disappeared for me for some reason, but I will drop those links in the chat if it comes back on my GoToWebinar at some point.
I should also plug Gandalf, right? So Gandalf is a great asset that, you know, it doesn't, we're getting marine heat wave aspects built into that, right? But there's a lot of other aspects of Gandalf that can help understand sort of, if you do see a marine heat wave, you can look and see what the circulation is doing. You can look at some of the overlays. It's a really nice resource as well. And so got to give GCOOS plug.
I was gonna say, yeah, thank you, Brian. I was about to do that as my last one. Yes, there's currently anomalies that are visible for those. I don't know how many of y'all work with glider data, but the ones that basically it's like a little mini submarine that goes up and down and can look at the whole water column. Right now, one of our staff members, Zhao, has already made it so you can see the anomalies for those gliders. So you can click around if you want to see that. But hopefully we'll have a little bit more tools available to look at marine heat waves on there soon. So keep an eye out in the next year or so for that.
Erin, could I be a bad moderator and ask a question?
Yes, and then we have one more question after you, and I think we might be at time, but go for it.
Fantastic. Yes, so we can jump into the marine heat wave reports. I'm curious if you're seeing any pinch points, kind of like you have certain areas where you form like North Atlantic deep water and things like that. Do you have any like pinch points that seem to be where marine heat waves are more likely to be formed than others? And if so, do you have any suggestions for where bottom temperature sensors might be needed to clarify that?
Well, if I was going to, I'll speak to the second half of that question. You know, regionally, I think in the Northern Gulf, there has been some work that's indicated that particularly the Northern Gulf is heating up faster and more intensely than the Southern half. Maybe Shawn can comment on that with some of the maps that I saw from him. But yeah, there's some other literature, like I said, that's published that. But in terms of bottom stuff, I think one of the things to think about is just sort of where things are important, right? Is where we should monitor, like, you know, the coral, the flower gardens, right? That's a really important resource for the Northern Gulf. And so understanding whether or not that's going to what that's experiencing temperature-wise is probably a good resource. You know, the Florida reefs, right? Things. And again, part of this is lack of knowledge, right? What do we know that's sensitive to marine heat waves, right? What ecosystems are at risk? You could even probably argue like the Northern Gulf in and around Louisiana and the Mississippi Bight, where we know hypoxia is affected by temperature, right? Places that may be more susceptible for risk to marine heat waves are probably places we should be thinking about monitoring more. As opposed to just where is a bottleneck or where is it happening more often. Well, if there's nothing really of interest, or not necessarily of interest, but that's not sensitive to a marine heat wave, then maybe it's not. We don't have to worry about that quite as much.
Yeah, I'll just add to that. One of the interesting things we found is that when we went to the higher resolution data set, so we went from 0.25 kilometers to 5 kilometers, or 0.25 degrees, sorry. So about 28 kilometers to 5 kilometers. The coastal areas really popped out in terms of their warming trends. That was true Florida Gulf Coast, Louisiana Gulf Coast, Texas Gulf Coast, and even down into the Bay of Campeche coast in Mexico. So I think, you know, we need to look more into it, but some of these coarser SST data sets may be missing some of that. And that would certainly argue for more monitoring, right, in those regions that tend to be, at least in spots, shallower and get warmer. But that was one big difference between the two data sets that really popped out to us.
I'm happy to share that we do have 2 wave buoys going in over the reef cap at Flower Garden Banks. It's a joint GCOOS and Socorro funded project. And so we're really happy to be able to be getting those data soon.
Yeah, great question. And hopefully we'll be able to get some more data sets as we go and continue building out, if we can, ocean observing, because that stuff is important. We have one last comment before we hop into kind of a closing, which is for Coral, which is, and also for anybody who wants to be in Houston, but a reminder that this year's American Meteorological Society annual meeting is in Houston in the 25th to 29th of January, and the suggestion that Coral's work might be worth presenting at the Environment and Health Conference. So that's a plug for you to maybe look into the AMS conference, see if that's of interest, from one of our audience members.
That'd be exciting.
Yeah, so talk to the meteorologist, talk to, maybe Shawn will be there too, see if we get the crew together. With that, I think we're towards the end of our webinar. I want to make sure that everyone has time to, go about the rest of your days. Chris, am I going first? Sorry, transparent facilitator moment. Do you want me to go and show things and then go to you?
Yeah, please do. That'd be great.
Perfect. Okay, we're gonna have a quick plug for a couple GCOOS things, y'all, so bear with me. One of them is that we've been working on some marine heatwave short reports. I think I mentioned this to a couple folks. Let me see. Can you, here we go, see my screen now? Are you seeing it? I don't know what y'all can see. Yes,
Yeah,
okay, great. Perfect. So this is our Marine Heatwaves webpage on GCOOS. It is literally gcoos.org/marine heatwaves. And on here, you can see a little bit of information on the project work we've been doing. But now we now have these reports that are up here that can tell you a little bit about what we found from our literature review on marine heatwave impacts on a lot of different species and ecosystems and industries. So for example, today we were talking about coastal temperatures and humidity, among other things. And then here we have our report for that, which is ideally short, sweet, but gives you at least a little bit of a sense of what we found from our review so far. So keep an eye out for those. Feel free to go and click on them. There will be some in Spanish as well that will be available in hopefully the next couple of weeks. So that's one plug. The second plug is after this webinar, you will be getting an email follow-up, and that's going to include 2 different feedback forms. One of them is a feedback form just to let us know how we did, see if you have any things that you would change for the future. But the second one is going to be actually a questions basically form. So if you have any other questions about extreme heat, about what that means for emergency managers, about what that means for any of you who do kind of especially management work related to extreme temperatures, we would love to hear from you. The folks at Mississippi Alabama Sea Grant are thinking about maybe doing a joint webinar with us in the future if we have some interest, and we'll pull in some more experts to answer your questions. So if you have anything, please fill that out, so that way we can make sure that we kind of address the needs of all of our folks who are interested in these kinds of questions. I think with that, I will pass it over to Chris to actually close us out.
Thanks, Ren. And thanks again to Brian, Shawn, Coral for today's presentations. They were really informative. And then just as a reminder, if you want to listen to these talks again, if you want to share them with your friends, if you missed any of the previous talks, you can listen to them on the GCOOS YouTube channel. Special thanks to you, Ren. Appreciate all your help and effort pulling these together, leading the charge on the webinar series. And if you have any suggestions for other webinar topics that you'd like to let us know, we'd love to hear about them. This is your forum to share things of interest to the GCOOS community, so please let us know. And we look forward to seeing you. Be well, and we hope to hear from you soon. Thanks, everybody.
Thank you all so much for joining us.